Quantifying anatomical diversity using discrete morphological features has become a popular method for examining macroevolutionary patterns in the fossil record. That approach allows paleontologists to utilize character states we normally use for phylogenetic analyses to examine the degree of anatomical overlap and potentially patterns of paleoecological diversification through time in different clades. To this end, disparity analyses are used as a method for analyzing macroevolution in our data sets to both augment and complement studies of species richness and phylogenetic patterns. For this project, I quantified the morphological diversity of mosasaurs from the Western Interior Seaway to contextualize macroevolutionary and ecological diversification within this group in a restricted geographic region. Mosasaurs are marine squamates that diversified during the late Cretaceous, and they filled piscivorous, durophagous, and macropredatory niches within the oceanic ecosystem. Mosasaur fossils are particularly abundant within the deposits of the Western Interior Seaway and Gulf Coastal Plain, being well represented in rocks that cover about 26 million years of geologic time. This allows us to quantify their macroevolutionary patterns and begin asking questions about the interplay between changes in the Earth system and evolutionary patterns and ecological patterns within this group of apex predators. The fossil record of mosasaurs from the Western Interior Seaway records a plethora of taxa representing all of the major groups of mosasaurs. Here at the what would be considered the subfamily clade level, you've got Tylosaurins, the low diversity Halisaurines, the much more diverse Plioplatycarpine mosasaurs, and the most diverse clade, the Mosasaurinae. For my disparity analysis, I scored 189 different features for 33 taxa from the Western Interior Seaway. These features were mostly pulled from phylogenetic character data sets. However, I also augmented those data sets with odd apomorphies and variable features that are normally not found in those sorts of data sets, because otherwise you're missing quite a bit of anatomical data that aren't quite as important for phylogenetic studies, but are useful if you're trying to understand anatomical diversity. I divided the geologic range of mosasaurs from North America into six equal length time bins, 4.5 million years each. And this really reflects the uncertainty that corresponds with some of our understanding of the biostratigraphy of different mosasaur taxa. Some we have some pretty precise biostratigraphic data for, whereas others we're not so sure about. We might know that they are from the Niobrara chalk, and nothing more specific than that. Now, one downside to using these coarser time bins is that it does lump together quite a bit, quite a few taxa that didn't actually coexist, and you'll see how that reflects in some of my results later. I quantified disparity using Graham Lloyd's Cladis package in R, using that to calculate pairwise dissimilarity through each of those equal length time bins. And then I tested for statistical significance in these data by calculating 95% confidence intervals. So these are my results for the disparity analysis. What you're seeing here are the pairwise dissimilarity data for all mosasaurs from the Western Interior Seaway, with the black dots being those dissimilarity values, and the lighter shaded area being the 95% confidence intervals for each of those time bins. And what you'll notice for all of mosasaurs, you actually don't see any statistically significant change in disparity through the late Cretaceous. I was actually surprised about this. I figured you would have some change in anatomical diversity through time, but Where you actually see that is when you start looking at individual clades of mosasaurs. So when we do that, let's first look at Tylosaurines. Tylosaurines are highlighted here in green, and I'll uh, call your attention to the second time bin where I have an asterisk. Here, you've actually got a number of species that are known from the Niobrara chalk that are lumped together in one time bin. You don't necessarily have all of these overlapping in reality. However, but because of these coarse time bins, they do, and that creates a spike in dissimilarity and disparity within that tylosaur clade. Halisaurines, highlighted in yellow, you see no disparity because you actually don't have any overlapping named taxa throughout this interval of geologic time. In blue here, you see the disparity within plioplatycarpines, big increase in disparity during the Santonian and continued diversity during this third time bin, which is the early to middle Campanian, and then a significant drop in disparity from there. And then finally, in the last time bin, no disparity because we're left with one taxon in North America. And then finally, mosasaurines, and this is one of the more interesting patterns. In that first time bin, I put an asterisk there because you actually see two taxa that are lumped together in that time bin that are separated by 3 million years of geologic time. The first of those, Dallosaurus, is an animal that in its postcranium very much resembles a terrestrial lizard, long limb bones, and that is lumped together in this time bin with something that closely resembles uh, things that we would consider Clydastes traditionally. So if we throw that out, you'll notice that from the second time bin, the Coniacian to Santonian into the early Campanian, you see a big statistically significant increase in disparity, and you maintain that high disparity throughout the remainder of the Cretaceous in these mosasaurines. Now, when we look at all of those different clades, all of those data combined, you can see a couple of different patterns. Our earliest named mosasaurs in the seaway are around 92 million years old, with some older scraps recognized here and there as well. But the big patterns that we see in disparity are jump out at us with two periods of anatomical diversification. First, with the plioplatycarpines within the Niobrara fossil assemblage, and then later on, highlighted in orange, with the big increase in disparity that you get with mosasaurines in the early Campanian, roughly between about 83 and 80 million years ago. And then that high disparity in mosasaurines is retained throughout the remainder of the late Cretaceous, while other clades see a drop off in in their disparity within those particular clades. Now, this is borne out in the if we map those same patterns onto the biostratigraphic distribution of all of these mosasaur taxa from the seaway. You'll notice highlighted here in blue, you've got a big diversity of plioplatycarpines. That's when you see the highest amount of disparity in plioplatycarpines as well. And then later on in time, highlighted here in orange, you see a big increase in anatomical diversity in mosasaurines, and that's also associated with an increase in taxonomic diversity within the group as well. And then you retain that high disparity in mosasaurines throughout the rest of the Cretaceous when you see a big diversification, especially in the portions of the skeleton that are associated with prey acquisition and processing. You get things like globidins, Prognathodon, and Mosasaurus all looking very different and very likely doing very different things in their ecosystem. And another part of this project that I explored was the role of intraspecific variation. This was something that I recognized while collecting these disparity data across all mosasaurs, is that some groups showed differing levels of intraspecific variation. So the taxa that I chose to look at specifically for this are the plioplatycarpine mosasaurs, Platycarpus, and Plesioplatycarpus, as well as the Mosasaurine Clidaces propython. Now for this, I ran the same metrics in Cladis, and on the next slide, you'll see those data shown here in this PCA plot, where you've got highlighted here in blue. These are the two plioplatycarpine taxa. In orange, you're seeing the single species Clidaces propython. So I think this is interesting because you've got two species here occupying a similar amount of morphospace as this single taxon Clidaces propython. Now, the variation that you're seeing in the plioplatycarpines are actually observed in bones like the quadrate as well as the skull roof, particularly the frontal and the parietal. Whereas in Clidaces propython, that disparity within that taxon is seen within the tooth-bearing elements. You can look at this by the numbers in these different features. Comparing plioplatycarpines here, you can see a sample size of 14 versus Clidaces, a sample size of 12. Quite a bit more variation in Clidaces in the length of the premaxilla and maxilla suture, as well as tooth counts in the maxilla, pterygoid, and dentary. Even a little bit of variation in Clidaces in whether or not you have tooth facets on those different teeth in the tooth-bearing bones. Now, why is that variation significant? Why do I think that ties in to this story of disparity? That variation shows up in early mosasaurians like Clidaces propython in these tooth-bearing elements. Now, that variation that we see intraspecifically becomes interspecific variation when you get into later mosasaurians. So, when you're seeing that big increase in disparity in mosasaurians and apomorphies between these different taxa, they're in the same elements that are highly variable in earlier mosasaurians. So this is a concept that's been discussed in the literature previously called a zone of variability. And is that an important part of the story for this diversification that you get in mosasaurians versus the lack of disparity that you get in other clades of mosasaurs later in their geologic ranges? So in conclusion, mosasaurs undergo two diversification events within the Western Interior Seaway related to their disparity or anatomical diversity. Now, sure, this is during a period of relative cooling. Could it be tied to their new physiology? That's something that I'd like to explore in the future. But I think something that's actually more important is that this increase in disparity in mosasaurines is potentially tied to that high level of variability early on in their evolutionary history. Selection acting on that variation to produce future disparity. What's driving that? That's really the next series of questions that I'd like to address with this group. I'd like to thank all of the museums that have hosted me throughout this research project, and finally, plenty of other folks to thank. And I thank you for tuning in for this virtual SVP talk.